Hi, my name is Zach Huffstetler, and I'm a senior civil engineering student at Clemson University. In the following video, I will discuss my flow project on the components of building a sustainable shed or cabin. First, I will take a look at what goes into building a sustainable structure. First component I will talk about is conservation of resources. Conservation is a basic principle of sustainability that seeks to decrease our human footprint on the environment. This means that we must put thought into the type and quantity of materials we use in the construction of a sustainable cabin. The next component I will talk about is functionality. Functionality is another somewhat overlooked aspect of sustainable construction. We want to make sure that we incorporate functional ideas into the construction of a sustainable cabin. Next, I will talk about efficiency. It could be said that sustainability is unachievable without efficient design. With this in mind, we need to focus on finding the most appropriate means of providing energy to our sustainable cabin. Next, I will talk about low maintenance. In order to reduce cost, our sustainable cabin should require a minimal amount of maintenance, especially since the cabin may be uninhabited for extended periods of time. And finally, I'll talk about durability. Durability is another vital component of a sustainable structure. A sustainable cabin should last for a long time as to conserve both money and resources for the long term. Now I will take a look at sustainable solutions that could be used in the construction of a cabin in the southeastern United States climate. I will begin by talking about sustainable flooring options. When selecting flooring for our sustainable cabin, we must look for a low-cost, durable material that can be found or produced nearby and is abrasion resistant. These are important factors that will help cater to the needs of a cabin that will likely be used by hunters or laborers. Now I will take a look at some possible materials that could be considered in our flooring selection. These materials include concrete, hardwood, carpet, cork, bamboo, marmoleum, and tile. All of these materials can be found or produced in the southeast. We can eliminate bamboo, cork, carpet, and tile based on their lack of durability. Out of the three remaining options, hardwood and marmoleum are shown to be more expensive than pouring a concrete slab. These factors would indicate that a concrete slab would be the most cost-efficient solution while still maintaining the cabin's durability constraints. Despite the fact that concrete is not widely considered a green material, it is the most appropriate for our cabin's purpose and our cost constraints. Now I will discuss sustainable ideas as it relates to the siding of our cabin. Like with our flooring, we want to find siding that is a low cost and durable material that can be found nearby. We also want to select a well-insulating siding due to the high summer temperatures in our region. This will ultimately help to make the cabin more energy efficient. Now I will take a look at several siding options for our sustainable cabin, including wood, engineered wood, fiber cement siding, insulated vinyl siding, brick, tin, and aluminum. With sustainability in mind, we can eliminate insulated vinyl siding, brick, and fiber cement siding due to their expansive carbon footprints. Of the remaining options, wood is priced considerably higher than tin, aluminum, or engineered wood. Wood also requires more maintenance over time than tin, aluminum, or engineered wood. If cost allows, I would recommend the use of wood in a sustainable cabin with the assistance of an effective insulation such as house wrap, sheathing, or foam. For a more budgeted project, I would recommend aluminum or tin siding due to its cost efficiency and relative durability. Now I will take a look at sustainable roofing options for our cabin. We want our roof to be dependable and appropriate for our warm and humid southeastern climate. We will consider several roofing options, including asphalt shingles, synthetic shingles, cedar shakes, cement tile, clay tile, slate tile, and metal roofing. We can eliminate asphalt and synthetic shingles because of their toxic composition and their lack of recyclability. We may also eliminate cedar shakes and cement tile due to their lack of durability and fire safety issues. Of the remaining options, I would choose metal roofing since it can be recycled, it's fireproof, and is lightweight. Clay and slate tile are other sustainable options but carry more cost and would likely require shipping to the southeast. Finally, I will take a look at some sustainable energy solutions for our cabin as it relates to providing electricity, water, heating, and cooling. For a small cabin, we must keep the occasional use of the building in perspective when choosing the power source. Now we will take a look at several power sources, including powered gasoline generator, propane, solar, wind, and water power. We can start by eliminating a generator due to its high cost and environmental hazards. We may also eliminate wind power due to the high turbine costs and the lack of ideal weather for the source in this region. Hydropower is also impractical due to the possible lack of continuous water flow for some users of the cabin. We can also eliminate propane since it will not provide electrical power without a generator. This leaves the solar power as the most appropriate and sustainable option for a cabin that receives occasional use. Small solar panel and inverter kits can be fairly inexpensive and maintenance-free. Solar energy also eliminates annual energy costs associated with other power sources. After reviewing the topics mentioned in this video, I believe that a sustainable cabin can be constructed at a reasonable price to the owner. Features such as a small solar panel, metal roofing, and proper insulation can help a sustainable cabin in this region to meet the needs of its owner while still operating in an efficient manner that allows the structure to have a long lifespan.